All right, let's take a look at the processing of the language of chemistry and types of reactions. So as a reminder, there's this helpful info about the basic formula for the combination reaction, the decomposition reaction, a combustion reaction, the 7 diatomic molecules, Hofbrinkel is what they spell. And then it also says the equations that you complete will not be balanced. That's okay for now. So first it gets into a little bit of some connecting air pollution with types of reactions. So it says acid precipitation is rain, snow, fog, or dew that has a pH less than 5.6. What are the two main causes of acid precipitation? Well, one of the main causes is burning of fossil fuels. And that's very general. And so this could be from factories, for example, industrial. And then also from the burning of fossil fuels from automobiles. Coal and oil contain sulfur, and when burned in factories and power plants, the sulfur combines with oxygen in the air and is emitted into the atmosphere. The gas undergoes chemical reactions in the atmosphere that result in the formation of acids, which eventually fall as acid precipitation. Sulfur dioxide is converted into sulfuric acid by 2 chemical reactions. So here's one, SO2 plus O2 makes SO3. That looks very much like the combination reaction. And then SO3 plus H2O makes H2SO4. That also looks just like the A plus B makes AB. These are combination reactions. Sulfuric acid can dissociate into sulfate ions and hydrogen ions, which lowers the pH, causing acidic environments that are very harmful to many ecosystems. So when this is breaking down into 2 parts, this is called decomposition. Automobiles and electricity, which largely relies on combustion, are the leading sources of nitrogen dioxide in the atmosphere. A small amount of NO2 is produced naturally by lightning, okay, but most of the time it's automobiles and electricity. The nitrogen dioxide gas then dissolves in water droplets to form nitric acid. What types of chemical reactions are these? These are, once again, combination reactions. Nitric acid can dissociate into nitrate ions and hydrogen ions, which lowers the pH, causing acidic environments that are very harmful to many ecosystems. So once again, it's showing a breakdown. This is decomposition. Complete the following combination reactions. Hint, crisscross charges to form products. Label the states of matter, but do not worry about coefficients to balance the equations. Lithium is in group 1A, so it's got a +1 charge. Oxygen is in group 6A, which has a -2. So when we crisscross, we get Li2O, and ionic formulas or ionic compounds are solids. Okay, second one, calcium's got a +2, sulfur's got a -2. So they just cancel each other out. So this will just be CaS. I'm just going to rewrite these so that there's no charges hovering above them. And then our last one here, Ag has a +1, chlorine has a -1. So this would just be AgCl. Complete the following decomposition reactions. Hint, break the atoms apart and look for the diatomics. So only if they're in Hofbrinkel do they get a number. So this first one, we've got Sr plus N2. Sr is a solid, that's a metal. N2 would be a gas. N is, of course, in Hofbrinkel. That's how I knew for it to have a 2. And then K2O would break apart into K plus O. K would get an S. For solid, O gets a 2 because it is in Hofbrinkel. And the last one, Na plus F. When they break apart, Na is a metal, and F gets a 2. It's in Hofbrinkel, and we label that with a G. Complete the following combustion reactions. Hint, the products are always the same. So the products are always CO2 gas plus H2O in a combustion reaction. So CO2 gas plus H2O. Number 9, complete the missing products or reactants and identify each equation as combination, decomposition, or combustion. So I'm going to just do a little highlighting first. I'm going to look for combination. That's when two things are being added together and it's not the combustion, so that one. And then decomposition is when you've got one thing breaking down. Ooh, there's 3. And then last but not least, combustion is, of course, following that pattern of fuel plus oxygen makes carbon dioxide and water. So let's start with this first one. This is going to break down. So Al plus N, and I'm going to label my state of matter here. N is in Hofbrinkel, so it's going to get a 2. So this will be ALS plus N2 gas. Okay, the next one is something adding, so it must be O2 in order for it to combine and make MgO. And then Mg is a solid, O2 is a gas. And then if we go back and we crisscross here to see what this was, it must have been NaCl. And then that ends up like that. Cu2O breaking down. This makes Cu solid plus O2. And so this will be a solid. And then the last one here, the combustion. This is a liquid, pentane. How would you know that? You could Google that. That's a tricky one. Is C5H12 a liquid or gas at room temperature? It's a liquid. So I guessed right. And then, of course, this makes CO2 plus H2O. And then write out the combination, decomposition, or combustion reaction that is described and complete it. So we've got aluminum, which is a solid, combines with chlorine gas. Chlorine is in Hofbrinkel, so it gets a 2. And then we're going to crisscross. So aluminum's a +3, chlorine's a -1. So this will be AlCl3, which is ionic, so that's a solid. Potassium oxide, K is a +1, oxygen's a -2. So this will be K2O, it's ionic. So it gets an S for solid. It decomposes, we break it apart into K plus O. K gets an S for being a solid. O gets a 2 because it's in Hofbrinkel and it's a gas. And then the last one, methanol burns. So this is a combustion reaction. So the products are going to be CO2 plus H2O. And I know that's a lot. It takes a lot of practice to get good at this, but keep working hard.